due to population growth, right? Okay, due to population growth. And then, what else? What will impact the load growth? Sorry? Sorry? Cakap kuat, tak dengar apa dia kata? Yes. Due to the economic growth as well. Okay. So, when we have economic growth, okay, economic growth apa dia? Abang? When we have economic growth, apa? When we have economic growth, economic growth apa dia? Pembangunan apa? Pembangunan ekonomi dia. Economic growth, betul tak? Pembangunan ekonomi, betul ke? Kenapa pembangunan ekonomi boleh jadi economic growth? Boleh menyebabkan load growth? Apa dia? Okey. Kamu nampak je kecil tapi kamu berbisa. Bagus. Jawapan kamu selalu betul. Cepatlah. Pasal rambut kamu tu rasa macam nasi ikat. Tapi bukan mahram. Kalau anak saya nasi ikat kan tu. Kan? Kenapa ya? Industri dia berkembang lah. Industri dia lebih banyak. So we have more industries. So mungkin dulu ada satu je kilang besi. Okay, for example, we have only one steel company to produce steel. So when we have economic growth, maybe we need more steel company. Okay, that's why instead of one, we provide electricity to one steel company. Okay, so we can have more. We need more power to supply more steel company that they can provide steel. For example, maybe heavy machineries. Okay, betul juga tadi kawan-kawan kata tu pasal teknologi advancement tu. Sebab semua barang kat dunia ni, any equipment in this world use power, electricity. Betul tak? Boleh tak kamu hidup tak ada elektrik? Can you imagine yourself, okay, live in this world, okay, today without using any electricity? Huh? Can you imagine, okay, your phone, okay, fully discharged? How long can you stay without your phone? Boleh? Living without phone, living without electricity boleh? Electricity cannot. Living without phone, yes. InsyaAllah, Alhamdulillah. Good. Oh, Masya Allah. Okay, living without phone, okay, still okay. Living without TV, still okay. Living without any, without your iPad, still okay. But without electricity, especially in Perlis during summer. Okay, even though Perlis is not like Middle East country, but I think that we also cannot withstand with the temperature here. Okay, so load growth, we need to make sure that the load growth. Sekarang ni, okay, what is the weather right now? Windy, kan? Lepas tu raining season, so we feel cold. So we don't need fan. Sometimes we need our air conditioning to work with lower temperature. It also will consume more power. Faham dah? Bagus lah. Saya suka Claire ni. Claire pun saya suka, jangan cakap dengan orang, nanti orang baca. Tapi saya rasa Claire ni menceriakan. InsyaAllah. Oh, factor. Load curve. So it is not constant. So for engineers, what you should do today? For electrical engineer, what you should do? You have to make sure that when you design a power station, you can always meet the load demand. Okay, to make sure that the consumer will not experience any apa? Any shortage of electricity. They will not experience any blackout. Betul tak? Tak turun-turun lah tu sampai malam kan? Kemas boleh ya? Kemas, bagus. Okay, the load curve is obtained by plotting the loads again the time on graph paper. So we have actually the load curve. So this is what we call 24 hours a day, daily load curve. Load curve is also called as load profile. Daily load profile. You want to see him with nice hair? Nice hair. Okay, daily load profile, monthly load profile, daily, annual load curve, annual load profile, 1 year, 8,760 hours. How do you get 8,760 hours, student? Kakak nama apa kakak? Ha? Uish, nama lebih kurang saya, tak boleh marah aku, nama Nisa. Nisa apa? Nisa Afika, kan? Kakak macam dia dapat ni 87 dan kosong 24 jam 24 hours multiply with 365 days per year. So you get 8,760 hours per year. That's what we call as annual load curve. The yearly load curve is generally used to determine the load factor. The areas under the load curve represent the energy. Okay, energy generated in period considered. Student, energy, what is the unit for energy? Tak payahlah nak British sangat. Dan apa? Kilowatt? Kilowatt hour. Kilowatt hour. Okay, so the energy that has been consumed over a period of time. The power that has been used for over a period of time is called as power that has been used for over a period of time. Apa dia? Energy. Energy lah. Power, kilowatt that has been used over a period of time. Berapakah power yang digunakan? Sorry, sometimes I have to talk in Malay. Kuasa yang digunakan kali dengan berapa masa kuasa tu digunakan adalah
Energi.
energi bahasa Melayu apa?
Kuasa.
Tenaga kinetik, tenaga apa elektrik, tenaga apa? Keupayaan tu semua tenaga kan? So it must be kilowatt times with time. Okay, so in this case you are using hours. Faham tak student?
Faham.
Okay. This is a typical commercial load curve. Area under the curve divided by the total number of hours give the average load on the power station. So the power station must be able to supply this load. What does we call this one, student? What we call this graph here? Load curve or load profile. Kalau daripada graph ni kan, kamu rasa apa aktiviti yang digunakan kat sini? Ha? Clement? Ha? Jadual got 2. This is commercial, right? So from subuh, people wake up, go to office and peak at 12 o'clock. And then slow down for a while after break and then pick up again when they go back. Okay, maybe around 3 it become peak again and slow down. People go back to their houses. So kamu boleh imagine tak bentuk apa ni? Normally the load curve looks like negara kita tak ada binatang tu. Oh, so it's like the back of the back of the camel. Taya, are you okay? Maybe you tired. Maybe you go somewhere, you can find camel. In Saudi, of course, right? The back of the load curve. Okay, the peak of the load curve normally look like a back of camel. Unggun unta. Ada 2 peak. Selalunya pagi, lepas tu petang. Kalau rumah kita?
Tengah hari.
Kalau rumah?
Tengah hari. Malam.
Pagi. Lepas tu pergi kerja. Sekali malam. Okay, kalau South Thailand, what the load profile looks like? Selatan Thai. Bagus. Malam tinggi. Siang tak ada apa, malam peak pukul 12, 3 pagi, pukul 5 turun. Faham tak? So, the load profile, you can actually faham tak? Tak apalah. Actually, from your load profile, you can observe what are the activities or what are the industries that is related to the consumers. So you have to make sure you have the data. So your power station must be able to supply according to the loads. So in Malaysia, we have this kind of load curve, but our foreign country, they really want the electricity supply during the night to support their industries. So what we should do? We can supply, we can sell our electricity to them during the night. Kan? Okay nah? So this one is the maximum demand. So you have to make sure that your power station, your generation station can supply this peak demand. The greatest problem of power supply company is varying load. Definitely, the load is varies. Betul tak? The load is betul tak? Generation should be matched with the load consistently. Okay. For example, your power station can supply up to 150 megawatts. Okay, is it possible for a power station to have only one generator that can provide 150 megawatts? Why you don't want to? Normally, engineers will not develop only one generator that can provide the whole power output, the whole capacity. Why? Yes, why?
The generator is fine.
Yeah?
The generator is fine.
Okay, if the generator is under maintenance, we have to do maybe it's broken or at fault, so we have to do maintenance. So what will happen to 100 megawatts load that is connected to the power station? Definitely, all of them will black out. So normally we are going to have many units. For example, 150 megawatts. Okay, so for example, for this case, it has 5 generators. For example, student, 150 megawatts, we have 5 generators. So for baseline, for base load, okay, so this one is what we call as base load. At any time, the our power station must be able to supply this load 24/7. It means that at all time we must produce this base load. Okay, this is the average load and this one is the peak load. So the base load is supplied by power plants running continuously, okay, 24/7. Our power plant at any time without fail must provide this base load. Okay, the intermediate average load prevails for some part of the day. So the green area here, okay, unit 3 and unit 4 generator must be able to operate, okay, for some part of or period during the day. And the peak load prevails only, which means that it will only operate only a few hours of the day. That's the peak load here. Okay, this one is the peak load. So it will only occur at several hours during the day. So the demand is the load at the receiving terminal. Okay, over a specified time, demand interval, maybe it is 50 minutes, 30 minutes, 1 hour or even longer. So if it's a quick change, okay, so means that we have to make sure that the load, we can supply the load, okay, and we have to check whether we supply exactly the same load that is required by the consumers. Okay, so this is the maximum demand of an installation or system. It's the greatest of all demands which have occurred during the specified period of time. Means that that is the maximum demand required by the loads. So how many loads that we have? Student, how many loads that we have? How many load that we have? Bagus. Apa dia? Industrial, residential, rumah. Satu lagi. Tapi tak cakap pun. Apa lagi satu? Apa dia satu lagi? Apa dia? Kamulah. Rambut macam songkok tu. Pandai. Good. Cakap kuat sikit. Bagus. Good. Bagi tepuk tangan sikit. Nama apa kamu? Farhan. Okay, good. Farhan. So load kita ada residential, commercial and industrial. Industrial loads. Okay, the demand factor is the maximum demand of a system to a total connected load of the system. So demand factor equals to maximum demand divided by total connected demand. Okay, so it is the maximum demand of a system divided by the total connected demand. We have diversified demand, which is the coincident demand. It is a demand of a composite group. Okay, means that we have mix of group of loads. We have residential, commercial, industrial, miscellaneous as a whole of somewhat unrelated loads. Definitely, residential is not related to commercial and is not related to industries. So we have to consider the loss in transmission and distribution over specified period of time. We have also utilization factor. It is the ratio of maximum demand of a system to the rated capacity of the system. So this one is utilization factor. Maximum demand divided by rated system capacity. What is the capacity of the power station? Seperti ini. Okay. Load factor, FLD. Ratio, nisbah of the average load to the maximum load during a given period. The load factor is always less than 1 because definitely the average load is always less than the maximum load. So, the greater the load, the less will be the cost per unit. Okay, so FLD, the load factor, average load times T, which is the unit served divide by maximum peak load times T. Okay, so T in time will be in days, weeks or months or years. We have also plant capacity factor. Total actual energy produced or served over a designated period of time to the energy that would have been produced or served if the plant or unit had operated continuously at maximum rating. So this is the plant capacity factor, which means that this is the energy produced. We have to divide by the, what is the plant capacity? What is the plant capacity? Multiply with the total number of hours. So this is how we calculate the plant capacity factor. Okay. Nisbah, ratio, total annual actual energy produced. Okay, this is the total actual energy produced over a period of time as compared to the plant capacity. Okay, as compared to the plant capacity. And then we have another one, previously is plant capacity, this one is plant use factor. Ratio, nisbah. Okay, how much energy produced in given time to the maximum possible energy that could have been produced during the actual numbers of hours that was in operation. Okay, so it is energy produced divided by what is the plant capacity with multiply with the actual numbers of hours that the plant was in operation. Okay, maybe our plant is not operate. Plan kita apa dia? Plan kita apa dia? Kamu rasa kan power station ni working 24/7, 365 days per year. Why? Because yes, our plant needs to shut down because we have to do preventive maintenance. Okay, our generators, maybe they need to check through visual inspection. They have to check the lubricating oil. Okay, what will happen to the motors of the lubricating oil? They have to check whether is in good operation, because definitely we don't want any generators to break down, to fail, unexpectedly. If we know there's something wrong with our generators in any of the power station, we can plan for the preventive maintenance. It is better and less cost as compared to when our system fail unexpectedly. Kan? Kamu boleh imagine your car, you know that your car needs to do some maintenance, right? Maybe you need to change only one bolt, satu screw je. Maybe you know that there is something wrong with that. If you don't do anything to your car, start with one bolt and then you have to maybe lagi banyak kena tukar, then the cost will be higher. That's why for engineer, it is preventive maintenance, it is predictive maintenance, PM. So for maintenance engineer is quite a lot of job that you have to do in order to avoid high maintenance cost. High maintenance cost means that before the equipment fail, you have predict well and you can control the shutdown time. That's the most important thing. When you have low shutdown time, what will happen to your plant? Lower shutdown days, what will happen to your plant? Definitely your plant will, as compared when you don't do any preventive maintenance to your plant, barang-barang will easily break down, and definitely you are going to have higher operating loss, day loss. Okay, and then definitely your profit also will be reduced, and your bonus, what will happen to your bonus? Maybe no bonus for you for that year. So in order to make sure that you get today, what is the oil and gas company in Saudi? Saudi Aramco, right? So normally Saudi Aramco will give you 8 months bonus or 10 months bonus. If you operate the plant and the plant suddenly shut down, and maybe you need more time to do the repair, maybe that time you don't have that 8 months bonus. So that's the main thing why we have to make sure that we have to consider. We have to consider the preventive maintenance for our plant. Okay, we have to consider that our plant need to shut down for maintenance job. Okay. So what is the diversity factor? Ratio of sum of individual maximum demand to maximum demand on power station. So each load has their own individual maximum demand. And what is coincident maximum demand, student? Student, what is the coincident maximum demand? The maximum demand of any of your loads, okay, occur at the same time. So that is the coincident maximum demand. Okay, TC is total connected demand, DF the demand factor, okay, the sum of it divided by the coincident maximum demand group of n loads. We have also loss factor. We have to consider the loss. Okay, we have to consider the loss. Is the ratio of the average power loss to the peak of load, peak load power loss during a specified period of time. So average power load loss divided by the power loss at peak load. So this is the coincidence factor. FC equals to 1 over FD. Okay. FD apa dia, student? FD apa dia, student? FD apa dia? Okay, good. Diversity factor. It is the difference between sum of the peaks of the two or more individual loads and the peak of the combined load. That's what we call as diversity factor by using this formula. 2 or more individual loads, the summation of 2 or more individual loads, okay, minus DG, the peak of the combined load. Okay. The generating station has maximum load of 20,000 kilowatt, and the unit generated being 61 million 500 kilowatt hour for the year. Calculate the load factor. So the unit served by your generating station is 61,500,000 kilowatt. Okay, so it's actually giga 61.5 gigawatt hour. So the maximum load, okay, is 20,000 kilowatt times with 365 days, okay, times with the 24 hours. Okay, it's actually divided by 8,760 hours. So the load factor, okay, the energy that has been served or generated is 61 million, okay, divided by the maximum load, multiply with 8,760 hours per year, times with 100, you are going to get the load factor 35%. Okay, power station has 2 megawatt, each running 7,500 hours in a year. One 30 megawatt unit running for 4,500 hours in a year. The energy produced per year is 750 times 10 to the power of 6 kilowatt hour. What is the plant load factor, capacity factor and plant use factor? Maximum demand is 80% of the plant capacity. What does it mean, student? The plant capacity, okay, the maximum demand is only 80% of the plant capacity. So the capacity of the power plant, you have 3 units, right? The 2 units, okay. So how many generators that this power station have? Ada berapa generator? Ada 3. So 2 units with 60 megawatts and the other unit is 30 megawatt. Okay, good. So the total capacity of the power plant is 60 times 2 plus 30, which is 150 megawatt. So the average load will be, okay, so this is the average load, okay, the unit served and then maximum load times the, okay, why 0.8 here, student? Kenapa 0.8 ni? Kenapa 0.8 ni? Okay, sebab the maximum demand given in the question 80% of the plant capacity. Okay, so we have to consider, we have to multiply with 0.8. Okay, and then plant capacity factor, energy generated by the capacity of the plant times what is the time. Okay, so we are going to get 0.57 for plant capacity factor. Okay, plant use factor, okay, the energy that can be generated by 260 megawatt, okay, and 1 kilo 30 megawatts unit. Okay, so for the first 2 generator, okay, the plant unit, the plant operates at 7,500 hours, and the 30 megawatt generator operate at 5,500 hours. So the energy that has been generated by these 3 generator is 1,035 times 10 to the power of 6 kilowatt hour, which means in gigawatt hour. So the plant use factor is 750, okay, divided by the total energy that has been generated. So 755 tu apa dia, student? Okay, the energy produced per year by the power station. Okay, the energy produced per year in the power station is 750 times 10 kilowatt hour per year. We divide it with the total energy that can be generated. Okay, that can be generated by the actual, okay, by the generator. Okay. Assume the annual peak load of a primary feeder is 2,000 kilowatt, at which the power loss, total copper, okay, student, why we use copper? At which equipment that we use copper? Why we use copper? Bagus. Copper we use normally at cable. Kamu belajar kan ya? ASCR. aluminium, steel, copper reinforced, kan, to transmission line. For cable, we use copper as well for distribution cable. So copper has been used as a copper has been used as a cable, or so in order to make sure that the loss we can calculate by using I square times R. The loss is 80 kilowatt per 3 phase, and the annual loss factor is 0.15. The average annual power loss and the total energy loss due to the copper losses of the feeder circuit. Okay, student, primary feeder apa dia, student? Primary feeder apa dia?
Energy lah.
Student? Feeder pillar. Ingatlah saya ajar gambar feeder pillar. Maksudnya daripada transformer tu dia boleh point of connection, primary feeder. Average annual power loss equals to power loss at peak load, which is given in the question 80 kilowatt time the FLS. So what is the FLS, student? Annual loss factor is 0.5. So this is FLS here. Okay. This one is .15. Okay, and then the average power loss is 12 kilowatt. The total annual energy loss, how do we get this one here, student? TAEL. Total, A is annual, E is energy loss, L is loss, Cu copper. So we know, we learn this from our science class or chemistry class, that the symbol for copper is Cu. So the average power loss, okay, multiply with the hours in a year. So you are going to get what is the total annual energy loss. Okay, 105,120 kilowatt hour. Okay, we are going to rest for a while, 5 minutes, and then we are going to continue.
Stop lah. Stop kan.